Hi, my name is Karsten. I'm a Principal Solutions Architect at Amazon Web Services. In this video, I cover how to test your application's performance on AWS Graviton. This is the second of 3 short videos on this topic. I covered the conceptual background for performance testing and migrations to Graviton in part 1. In part 2, I cover how you reduce cycle time by using a containerized test harness and Kubernetes native deployment constructs to automate test execution. Specifically, I show you how to build and publish cross-platform container images in Amazon ECR, orchestrate test execution using container-native workflows in Amazon EKS, provision and deprovision test notes using Carpenter, and collect and export metrics, logs, and traces to Amazon CloudWatch for data retention. Before you can try this on your own, make sure that you have the most recent versions of these prerequisites installed on your developer workstation. More on this later when we cover our GitHub repository. In the following slides, I will cover an example workflow to help you build, run, and observe a test case under load. I've packaged our recommendations for how to make this process repeatable and published it as a code repository under AWS samples on GitHub. But first, let's go over to GitHub to take a peek at what's inside that repository. I start by navigating to AWS samples on GitHub. This page contains code samples and walkthrough labs for popular AWS topics. I use the search bar and enter Graviton Performance Lab. Next, I click on the Sample Graviton Performance Lab tile to navigate to the code repository. Once on the page, I review the README file for information on how the repository is structured, what resource types are covered, and then instructions for getting started. I then follow my preferred way of cloning the repository to my local file system. My first workflow step is to build a cross-platform container image of my test client and application, which I can then use and schedule onto a new or existing EKS cluster. First, I build and publish a cross-platform container image of my example application in Amazon ECR. I use a Docker file to provide instructions for how to build my application's source code. In my example, I've written a Java Vertex API endpoint that implements a simple object model and REST API. I will come back to the sample application later on when I generate the load profile for my performance test. Next, I specify application dependencies such as the language runtime required to run my application. In my example, I use AWS Graviton, a multi-platform, production-ready distribution of the Open Java Development Kit, or OpenJDK. The Docker file allows me to specify the Java version and JDK vendor that I want to use. By choosing AWS Graviton, I know that AWS has provided platform-specific optimizations that speed up cryptographic operations and other use cases on Graviton. Finally, I make sure to include native libraries that offer assembly-optimized implementations for the target platform. I won't have time to go into detail here, but this may be required for performance-critical applications and use cases such as cryptography or vectorization. I can now use the Kubernetes scheduler to schedule a build job and then publish the resulting cross-platform container image to Amazon ECR. Next time I create a Kubernetes pod, the scheduler will then pull the optimized container image that matches the CPU architecture of the underlying worker node, as illustrated in my diagram. Let's see how this looks like in the Kubernetes command line interface. I start by creating an image builder resource. Kubernetes parses the manifest and then schedules the requested resource onto a suitable worker node. I can monitor the state of resource creation via the getPods command. Once created, the image builder will build my application and install dependencies. I can monitor the application build and packaging progress by inspecting system logs. Once complete, the image builder publishes a cross-platform container image to Amazon ECR. My second workflow step consists of running my test case using a container-native workflow engine. In my example, I use Argo workflows to schedule and orchestrate activities that are part of this workflow. Let's go back and remind ourselves what happened during the previous step. With the build step complete, I can turn to performance testing different combinations of application code, runtime versions, and CPU architectures. The nice thing about Kubernetes is that everything's declarative, so I only have to change a few lines of code. For now, I'll proceed with my example. In order to test application performance, I need to subject my application to different load conditions. In my example, I use a load generation tool called WRK to simulate HTTP traffic hitting my Java Vertex web endpoint. I can configure the test duration, threads used to generate load, the number of open HTTP connections, and the constant throughput in requests per second that I want to achieve. This allows me to gradually ramp load on the system and capture accurate RPS and latency profiles during my test. As before, I'll demonstrate this using the Kubernetes command line interface. I start by creating a workflow resource. I inspect the workflow execution state by calling the getWorkflows command. I see my workflow has created two pods, one containing the WRK tool and the other my Java Vertex endpoint. Kafka takes care of provisioning and then deprovisioning test nodes in the background. Using the logs command, I can monitor events written by the test tool to standard out. My workflow engine automatically terminates pods once they are no longer needed. In my final workflow step, I configure my test environment to ship logs and other data to AWS CloudWatch. Let's go back to the previous step for a moment. I can change load profiles or application configuration to test different combinations and test conditions. But how do I preserve test results beyond the workflow and container lifecycle? The answer is by installing the AWS CloudWatch container agent on worker nodes to collect and export metrics, logs, and traces to AWS CloudWatch. With my test setup complete, I can focus on writing new test cases, knowing that test results will be automatically shipped to AWS CloudWatch for data retention. Let's see how this looks like in the AWS console. I log on to AWS and navigate to CloudWatch logs inside. In my example, I want to inspect log events generated by my performance test. I start by selecting the corresponding log group and then write a simple query to list matching log events. I submit my query and then start scrolling through the results. Each log event tells me per thread statistics, including average latency, standard deviation, max values observed, and so forth. The log events persist beyond the lifecycle of the test cluster, so I can go back and compare different test runs.